Today we are going to work on DynamoDB. When I say DynamoDB, it's a NoSQL database provided by AWS. I hope you know the difference between NoSQL and SQL database. In NoSQL database, we have the flexibility that we don't have any limitation from this engine that you have to define a fixed schema. In the case of NoSQL, it is not a, you can say, impulsion to have a fixed schema. For a single record, you can create multiple columns and different columns, and for another record or another item you can create different number of columns. And this is one of the managed service, that is fully managed database by AWS. It support both, one is JSON, XML and key value store models. When I say JSON, you can store JSON type of document on the DynamoDB. Then there is another feature which we call it TTL, time to live, because if you talk about SQL, MySQL, Oracle, there was a problem, right, how to delete the data which is not needed. So here in the DynamoDB we have the feature with the name of TTL, which we say time to live feature. So you can define a record, you can define a time for a record, that how many days you want to retain that information in a system. Let's say today is 23rd of December 2022. In that case, I want to store certain record for only 1 month. In that case, you can define the TTL feature, TTL time to that particular record. I will show you how to do it. When I say no fixed schema, it is not a compulsion. Like I said, it's not a compulsion that you should have a schema, fixed schema. Like most of the RDS follow these rules, relational database systems. Designed to scale out using distributed cluster of hardware. Basically, what AWS is doing in the background, they are creating distributed cluster of hardware to serve traffic. So it is very useful feature, or you can say it's a very important database when it comes to gaming, when it comes to IoT devices. The flexibility, the scalability model is very good in the DynamoDB when you start comparing with the RDS, or which is known as SQL. The lot of features comes extra when you talk about DynamoDB. These are some of the benefits, like cost-effective provisions, AWS set of services support. These components you need to remember when you work with other databases. You call it database. Here in the DynamoDB you call it database, same naming convention. But in other database we call it table. Here we call it item. I think table we call it, one of the attributes missing. Then for a single record we call it item. For column we call it attribute. Then we have concept of primary key, secondary key and global secondary index that I will explain later, but with the name you can understand primary key is your mainly primary key for that table, because that is a thing compulsory to create a table in DynamoDB. Tables. Similar to other databases, DynamoDB stores data in tables. A table is a collection of data. Items, like I said, it's a record. It's a group of attributes that is uniquely identified among all of the other items. We'll see in action. But one of the example I want to show here you, that this is example of table I'm talking about, because I'm just emphasizing on one point, that there is no fixed schema in this table. One record has a person ID, last name, first name, phone. Another record has person ID, last name, first name, address, and it has a array values. Then third record has person ID, last name, first name, address and favorite color also. So if you see carefully, there is no fixed schema in every record. Here we have 4 columns, here we have 4 columns, but different names. Address was not available here, address is available here, phone number is not available here. In the same way, for this record we have 5 columns including array of address. So that is the perfect example for no fixed schema. These are the differences I was talking about. SQL terms, we are calling it database. In DynamoDB also we are calling it database. In SQL terms we call it table. In DynamoDB also we call it table. In SQL we call it row. In DynamoDB we call it item. In SQL we call it columns. In DynamoDB we call it attribute. In SQL terms we call it primary key. In DynamoDB also we call primary key. And in the place of index we call it secondary index, and view we call it global secondary index. And this was I was talking about. This is very I would say important to understand when you are working with DynamoDB, because the DynamoDB works on this pattern, WCU and RCU. What is the meaning of WCU and RCU? The write capacity unit and the read capacity unit. For this, let's go to Notepad and understand what I'm talking about. When you say you want to write data to your table, let's say you are creating one of the table with the name of employee table, and you are saying I want to write data to that table. Before writing a table, you have to create a table, and while creation of table, AWS will ask you what is the WCU and what is the RCU. That means write capacity unit, we call it WCU. So WC is something that you can, each API call to write data to your table is a write request. So it's 1 KB of request inside would become a 1 request for you. So let's say if I am saying I am taking 5 WCU, that means I can write 5 KB of data in single second. So 1 WCU is equal to 1 KB of data, right? That's how you can understand. Now you will ask how to calculate this 5 KB of data in single second. Let's say if you're saying I have employee table and I want to write 20 records in single second. How you will differentiate, how you will get it, this figure, by it depends on your application load actually. So if I'm saying in a single second I would be writing 20 records, and that 20 records will be of 200 bytes, multiply 20 records, how much it would become? 4000, right? 4000 bytes, that is equal to 4 KB. I'm just roughly calculating, it will become 4 KB. So that 4 KB, for that 4 KB you only required 1 WCU. For this load 1 WCU is enough. Now the second term comes into the picture, we call it read capacity unit. How much you will be reading out of it, out of this table. Let's say I'm saying for reading there is a different rule. 1 RCU can read 4 KB of data per second. 4 KB for read capacity unit. If you are saying I am reading 50 records per second, and one record is having 200 bytes, then how much it would become? 10,000 divide by, it will become 10,000 bytes, which is roughly equivalent to 10 KB of data. Then AWS will take 3 RCU, which is equivalent to 12 KB of data. So if this figure, which is 10,000 bytes, is going to reach 17,000, let's suppose, in that case AWS will take 4 multiply 4, 16 plus 1, 5 RCU. In the case of 17,000, it will take 5 RCU. Why? 4 KB multiply 4 is equal to 16,000 bytes plus 1,000 bytes are still left. AWS will take 4 KB for that, 1 KB for that. So in total 5 RCU will be required. So that's how you will design your table. I will let you know in action, but I'm just telling you the basics of it. Now go to DynamoDB. Once you go to DynamoDB, click on tables. This is a dashboard. Click on tables and create your table. I'm saying I'm creating a table with the name of customer partition key. When I say partition key, it is your primary key. So I'm saying customer ID. I'm taking it as a number. Very basic table I will be creating. Sort key is equivalent to, for you can say on a single table we can create one primary key, but if you want to search with other columns also, then you will adding a sort key. So I will cover a separate example on it, but this is very important. This was I was explaining to you. While creating a table, it will ask you the capacity mode. The capacity mode is provisioned. When I say provisioned means it will be fixed, 5 RCU and 5 WCU. So that means if your load is increasing in the future, you cannot automatically, it will not be increased because you are keeping it on the provisioned, which is fixed. So 5 RCU means 5 read capacity unit. 5 WC means 5 writing capacity unit. And this is what AWS is saying. Can you edit this field after creation of table? Yes, almost every field you can update it. But I will not go with default settings. I will go with customized settings so that I can explain you all the features of it. Click on customize settings. Here it will give you two options. One is DynamoDB standard. One is DynamoDB standard IA, infrequent access. So in my case, I want to create a standard table because I want to go with higher availability concept here. If you go with standard IA, it will save you money. But I'm going with, to explain this feature, I'm going with DynamoDB standard. Capacity calculator. Capacity calculator is the thing where you can calculate your cost. Like I'm saying on my this table, customer table, I'm going to write a record which is 1 KB. Every item is 1 KB. How much read operation you need on that table? In a second, I'm saying 10. How much writes you will be doing per second on this table? I'm saying 20. In that case, AWS gives you this. Read capacity you need is 5. Write capacity you need is 20. And you have to calculate this formula like the way I did. This is the same calculation I did here. So I explained manually to you, but you can use this calculator also. And there is a property also, read consistency, which says eventually consistent means which are committed, which records are committed as of now. One is strongly consistent. When it says strongly consistent, AWS will also give you feature that records which are not committed but in the you can say just going to commit in some time, they have an open transaction, in a few seconds they will be committed. In that case, do you need to wait or not? But I will cover a separate example on it. But for a timing, you can understand I am going with eventually consistent, which is equivalent to just committed records. This is just a calculator. You are not defining the things here. This is the actual thing I'm going to explain you. Read write capacity unit. If you are saying, hey, I'm not sure about my load as of now, it can be go up, it can be go down, and AWS should take care about it. In that case, you can choose this option, on demand. Everything will be owned by AWS. Simplify billing by paying for the actual read and writes. But I'm saying I'll go with provisioned. In the provision itself, AWS gave you two options. Can you go with auto scaling on? When you say auto scaling on, you have to define the minimum capacity unit, the maximum capacity unit, and the target utilization. I'm saying, yeah, I would go with auto scaling. Minimum capacity unit I need 5. Maximum it can require up to 15, and target utilization is 70%. So AWS is asking you that on which parameter should I increase or decrease. So based on capacity unit, if one capacity unit is busy with 70% utilization, then AWS will take an action on it. So in this case, auto scaling case, it gives you two options. One is on, one is off. When I say click on off, it will give you exact provision capacity, how much is you are looking for. I'm saying 10. That is also option. If you want to go with auto scaling on, then you have to define this figure. But if you want to go with off and just saying 5 provision capacity unit, that is also fine. And basis on this, your charge will be different, whatever capacity you are choosing here. In the same way, writing capacity, auto scaling, on, off, I'm saying off, and go with provision capacity unit 5. You want to create index as of now? I don't want to create an index as of now. It is showing you the total read capacity unit is 5, total write unit capacity is 5, and let's create a table. Click on creating a table. Till the time this is being created, I will explain you how to calculate the cost in the calculator for these tables. Go to AWS calculator, look for a feature in DynamoDB, create an estimate, and go to DynamoDB. In DynamoDB, I'm not looking for provision capacity. Let's go. Okay, chalo, that's fine. Go with DynamoDB provision capacity first. Table class standard. How much data storage you have on the table? Let's say my table is having 20 GB of records. So I'm saying data storage is 20 GB. Average item size is 1 KB. This is taking your 31.14 US dollar. And why upfront? What option? Okay, they are choosing provision capacity. So let me go to default one, which is on demand, and close this one. I'm saying load is 20 GB, 5 US dollar, and on demand write settings. I'm saying number of writes will be, let's suppose 400,000. You have to calculate by your application load, and million, not million, here you have to choose per month. 400,000 records I will be writing per month in this table. And on demand read settings, I'm saying 600,000 records I'm going to read every per month. So this would be a cost $6 USD. Go back and check your table is available. Refresh, table is available. Let me go to this table, click on it, and here it will define you that this is the customer ID is a partition key, sort key is not available, capacity mode is provisioned, table status active, no active alarm. These are table summary, and here you can see table metrics, read usage, read throttling events, how many write requests are coming, everything you can see in the metrics basically in the CloudWatch. But let me write something to this table. Click on this action buttons and click on create item. Let me add some of the records. Like I'm saying customer ID is 1. I'm adding an attribute string and give it a value like name, and name I'm giving is Rajesh, and one more attribute I am adding which is number and call it age 45. Create item. In the same way, let me create one more record, create item, customer ID 2, and this time I will be taking a different field here. Let me take one string, call it name, and I'm calling it Chad. One more attribute, instead of age I'm taking salary, and the salary I'm keeping it 10,000. Create item. Now if you see carefully, what has happened is for the first record it is customer ID, age and name. For the second record it is customer ID, name and salary. Age is not available. This was the thing I was talking about. It's a fixedless, not fixed schema. Everything you can define for the single record, not for the entire table. So you have done the creation of items. In the same way, you can query the data, scan or query items. If I click on it, there are two options. One is scan, one is query. When I say scan, without any attribute, it will run and it will scan your entire table. Like if I'm clicking on it, entire table is scanned, and this is bad operation actually. It will take a lot of your read capacity units. And when I say query, in the case of query, it will search basis on partition key. In our case, partition key is customer ID, right? And I'm saying customer ID, whosoever is customer ID 1, just return that record. It is returning only 1.